Here we go. It's time for us to do some homework. It's your favorite. Hey Wildcats, welcome. Today we're going to be looking at the 2.2 homework section. So let's go ahead and take a look at exactly what it's got set up for us. So this is 2.2, our first problem. It's asking us to solve the absolute value equation by graphing. So since it equals 4, we're going to look for one with a red horizontal line at 4, and it looks like all 4 of our graphs have that. So it does look like, other than that, we need a graph that has been moved 2 spaces to the right and 1 space up. So 2 spaces to the right, 1 space up. Looks like it's going to be A. So now it's asking us to enter our solutions. The solutions to this are where the x values for where it crosses. So I see -1 and 5. So x is -1 or x is 5. Correct. Perfect. Part 1, part 2, both correct. Exact same question. Once again, the red bar is at the correct spot, 6 for all of them. This time, though, we are looking for a graph that has been moved 1 space to the left, 4 spaces up. So, I see this is 4 and 1, this is 4 and 1, this is 1 and 4, but we said 1 to the left, so 1 to the left, 4 up. Next, they want, once again, the solutions. So we have -2 and 0. So I'm looking here at the x-axis where it crosses and they intersect each other. So -2 and 0. Alright, number 3. Same exact thing. We do know that the graph is opening down, but all 4 of them open down. We're looking for a graph that has been moved 5 to the left and 4 up equals 1, which means the red bar has to be at 1. So this red bar is at 5, so it's not A, could be B, could be C, not D. So it's either B or C. 5 to the left and 4 up. This is 5 to the right. This is 5 to the left. So it is C. And our solutions are going to be, let's see, this is 6, 7, 8. But that isn't quite to 7, so this is looking like -6.5 or -3.5. Yeah, and we could have gotten that because it says nearest half unit. Alright, solve the absolute value equation of this by graphing. So we know that in order to solve it by graphing, well, since they're asking us to do it by graphing, that's easy enough. We're going to have something that moves 1 space to the left, 6 spaces up. 1 space to the left, 6 spaces up. And we need it to the red bar to be at 2. Now we can see that the blue and the red do not cross, therefore there are no solutions. Solve this algebraically. Graph the solutions on the number line. So we do have to be careful with these ones. In order to solve this algebraically, we've got the absolute value of 3x equals 7. And as we've mentioned in class, once we've isolated the absolute value equation, which this already is, we're going to divide it into 2 halves. So we're going to have 3x equals -7 and 3x equals +7. Since we're multiplying by 3, we're going to divide each side by 3. X equals -7/3, which is going to be negative 2 and 1/3. And then we're going to have the same thing over here, divide both sides by 3. And 7/3 is the same as 2 and 1/3. So this could either be written as 7/3 or 2 and 1/3, either way. However, I'm a little worried about coming up with exactly a third on this scale, but let's see what we can do. So our smaller value, we're going to click smaller value, is at 2 and 1/3, which is about there. And the larger solution is at 2 and 1/3, which is about there. Okay, looks like you just have to get close on those. Definitely makes it a little bit easier. Alright, once again, we're solving an equation. So absolute value of 1/3 x plus 2 equals 3. And again, our first step is to isolate the absolute value, which has already been done for us. So step 2, divide into 2 halves. We have 1/3 x plus 2 equals 3, negative 3. And 1/3 x plus 2 equals positive 3. So we subtract 2 from each side here. 1/3 x equals negative 3 minus 2 is negative 5. Divided by times 1/3. In order to get rid of that, we can multiply by the reciprocal, times 3 over 1. So we're multiplying by 3. X equals negative 15. And on this side, we're going to have 1/3 x, we subtract 2 from both sides, equals 3 minus 2 is 1. Once again, we multiply each side by 3 by the reciprocal of 1/3. X equals 3. So negative 15 and 3. Smaller solution is negative 15. Larger solution is 3. And it would be nice if they wouldn't make us guess where the middle is, but they're not that nice. So 7, solve this algebraically, graph on a number line. Alright. 3 times the absolute value of 2x minus 8 plus 6 equals 10. So this time it did not start out with the absolute value already isolated, so we're going to have to do that first. Subtract 6 from both sides. 3 times the absolute value of 2x minus 8 equals 4. 10 minus 6 is 4. Divide each side by 3, we get 2x minus 8 equals 4 over 3. Divided by 3 because that's what we were multiplying by over here. Now we can split into 2 halves. This is 2x minus 8 equals negative 4/3. And this is 2x minus 8 equals 4/3. Add 8 to both sides. 8 times 3 is 24, minus 4 is 20, so this is 20/3. So 2x equals 20 over 3. Divide each side by 2, we get x equals 10 over 3, which is the same as 3 and 1/3. On this side, we add 8. Once again, 8 times 3 is 24, so this is 24/3. 4 plus 24 is 28. So this becomes 2x equals 28/3. And when we divide both sides by 2, this becomes 14/3. So we have 3 1/3, and then 14 is 12 would be 4. So this is 4 2/3. So we're looking for 3 1/3 and 4 2/3. Wow. Thank you, fractions. about 3 1/3 is there, and about 4 2/3 is there. As I keep telling you guys, I know you probably prefer decimals over fractions, but Algebra 2 uses a lot of fractions, and the math will be much easier if you just work with me, get comfortable with fractions. We're going to use them a lot. So, number 8. Consider this absolute value equation. How many solutions are there to the equation? Well, all we have to do, like we said previously during our notes, is to isolate the absolute value sign, and then we'll know how many solutions there are. So 1/3 absolute value 1/2 x plus 5 plus 6 equals 4. Alright, so starting with PEMDAS backwards, we've got minus 6 minus 6. So 1/3 absolute value of 1/2 x plus 5 equals -2. We have times 1/3 here, so we multiply by the reciprocal. 3's cancel out, 1's cancel out, we're left with 1/2 x plus 5. -2 times 3 is -6. So now we have an absolute value that equals a negative number. Remember, if it equals a positive number, that's 2 solutions. If it equals 0, that's 1 solution. And if it equals a negative number, that is no solutions. So since this number is negative, the answer is no solutions. How do you know there are no solutions? An absolute value cannot be equal to a negative number. Alright, once again, same basic question. -1/4. Absolute value x plus 6 plus 3 equals 8. Subtract 3, subtract 3, -1/4 x plus 6 equals 5. 8 minus 3 is 5. Reciprocal of -1/4 is -4/1. Cancel, 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 cancel. Multiply by -4/1. 5 times -4 is -20. Absolute value of x plus 6 equals -20. Once again, we have an isolated absolute value sign that equals a negative number. That tells us that there are no solutions. How do we know that? Because an absolute value cannot be equal to a negative number. Next question, number 10. Consider this absolute value equation. How many solutions are there? Once again, we can do the same basic thing, but we have to watch out for the parentheses here, guys. So we have 2 parentheses, absolute value x plus 4 plus 4 equals 8. So watch these parentheses, because when we do PEMDAS backwards, you would normally start with this addition and subtraction at the end, but it's inside parentheses. So because it's inside a set of parentheses, we have to skip it and come back. So since there's no addition and subtraction, we're going to do multiplication. Opposite of times 2 is divided by 2. Absolute value of x plus 4 plus 4. And then 8 divided by 2 is 4. Subtract 4 from both sides. Absolute value of x plus 4 equals 0. So since this is an isolated absolute value sign that equals 0, we know that there is exactly one solution. And they want us to graph the solution on the number line, so x plus 4 equals 0. Subtract 4 from both sides, x equals -4. So we are graphing x is -4. Next question. Consider this absolute value equation. How many solutions are there to this? Absolute value 4x plus 9 plus 7 equals 6. Subtract 7 from both sides. Absolute value 4x plus 9 equals minus 7, 6 minus 7 is negative 1. Isolated absolute value sign equaling a negative number is no solution. Absolute value cannot be equal to a negative number. Number 12. Solve the absolute value equation, blah, 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 blah. If the solution is not an integer, give it in fraction form. So this is a good example where they've given us this problem and we can solve it any way we want. I'm just going to write down the problem. Negative 7 absolute value of 3x plus 2 minus 2. And then on the other side we're going to have equals negative 2. So the reason I've written this down is because I actually want to switch over to Desmos. And we're going to graph this one. So we have negative 7 absolute value of negative 3x plus 2 minus 2 equals, so y equals negative 2. Find our point, click it, negative 0.667. Well, that's not a fraction, is it? That is definitely not a fraction. So let's see, do we have any way to let us do this? 0.667. Yeah. So if you type in the 0.667 that they gave you, and you click this right here, it's going to give it to you as an approximation. Unfortunately, that's not quite accurate either. And it doesn't matter how far out you take this, it's not going to let you put it into a fraction. So this is one where you have to know that 0.6 repeating is 2/3 as a fraction. So if you do this in your calculator, you're going to need to know that. If you were to do it by hand, you could have gotten it as a fraction without ever going to decimal. So let's go back to our problem, and we need fraction 2/3. Check answer, correct. Next question. Next question. Alright, so we have a flock of geese is approaching a photographer flying in formation. The photographer starts taking photographs when the lead goose is 400 feet horizontally from her, and continues taking photographs until it is 100 feet past. The flock is flying at a steady 40 feet per second. Enter and solve an equation to find the times after photographing begins that the lead goose is at a horizontal distance of 80 feet from the photographer. So our equation is d of t equals, they start at 400 feet away and they get 40 feet closer every second. So every second we subtract 40 feet from their distance. So we're looking for here the absolute value of 400 minus 40t. And they want us to solve this, so I say we solve this with Desmos. And if we're going to solve this with Desmos, we need the absolute value of 400 minus 40t. Sorry, we're going to have to put x here. Equals, and then y is going to equal, they said, how many feet? 80? Horizontal distance of 80 feet. So 80. Got two solutions here and here. We are at 8 and 12. So we need 8 seconds, 12 seconds. Next question. Terry is trying to place a satellite dish on the roof of his house at the recommended height of 27 feet. His house is 24 feet wide, and the height of the roof can be described by the function that, where x is the distance along the width of the house. Complete the absolute value equation and examine where Terry should place the dish. So he wants it at a recommended height of 27 feet. So clearly, this has to equal 27. So what we need to do is we need to plug this into Desmos again. We are going to have negative 3 halves, absolute value, x minus 12 plus 18, and the height is going to be 27 feet. Alright. Desmos. So, negative 3 halves absolute value of x minus 12 plus 18. And on the other side, y equals 27. That doesn't look like it ever gets up to 27 feet. Oh, well, it's a good thing that that is one of the options. Oh, oops. Go back so you can see that. So going back to the website, so we said 27, but as we see on Desmos, there is just no place where this crosses. So looking here, we can see that one of the options is there's no place on the roof that is 27 feet high. So, for what type of real world quantities would the negative valued answer for an absolute value equation not make sense? Generally speaking, time, you don't have negative time. You don't generally have length. You don't generally have negative distance. Temperature can be positive or negative. I'm going to say bank account balance, but do know that your bank will let you go into the negative, but they're going to make you pay them back. Okay, so have you ever written a check for more than you had in your account? What was the balance in your checking account? Okay, that's what I was just saying. You can have a negative balance in your bank, but they're going to make you pay it back. So apparently I tried to overthink the book. So there you have it. There is 2.2 on your HRW assignments. With that, I will leave you guys to it. Have fun, Wildcats.